Hi, I'm Michael. Geometry is one of the subjects we will face in the quantitative section. On the one hand, it's the smallest subject. We should expect to see around 7 to 9 geometry questions in a section, out of 37 total. On the other hand, this is the GMAT topic with the most rules we have to study, and thus it requires a lot of work. One thing that makes geometry questions special is that in them, information can come from several different sources. First of all, as with all GMAT questions, there's information to be found in the question itself, meaning it's text. But in geometry, information can come from 2 other sources as well. The first is the rules of geometry from the following topics: lines and angles, triangles, quadrilaterals, circles, polygons, coordinate geometry, and solids. To be ready, we have to study all of them. There's another source of information which is unique to geometry. That is the figure, which often appears next to the question. These figures may add certain information that we don't find in the text. When observing the figure, it is important to know that in the test, if a line segment looks straight, it is straight. If lines, curves, or edges appear to have a vertex, that is to meet, they do. On the other hand, there is information in the figures which we cannot trust, such as the length of line segments and the size of angles. So, an angle which looks obtuse can be acute. Calculation might show it. A line segment which looks short can be long. Again, it's all in the numbers. It's especially important to remember this fact in data sufficiency questions, which are all about figuring out what we can and cannot know. For example, in this question, we are asked if AED is a right angle. Although it definitely looks like one, we must ignore this. The figure could be drawn in many different ways, and we can't trust it. In fact, we have to combine both statement 1, which tells us AEB's angle, and 2, which tells us BED's, to discover that AED is, in fact, 90 degrees. An opposite case where we can trust the figure entirely is when we are shown a figure which can only be drawn in one way. This is the case with regular polygons. For example, in this question, we are told the blank figure is a regular hexagon. Since regular hexagons, by definition, always have equal sides and equal angles, there's no alternative way to draw this figure. Because of this, we can use the figure, cutting it into pieces, and trust the way they look to solve the question. In this case, the shaded triangles are each equal to the pieces we cut, and thus they make up 4 out of 6 pieces, which make 2/3 of the hexagon. Sometimes we'll be asked a geometry question with no diagram at all to go on. In these cases, our natural inclination is often to start drawing, but this is not necessarily the right impulse, as this takes time and could confuse us. Before we put our pen to the paper, let's ask ourselves, is there logic in the question we can use? For example, if we are told 2 angles are adjacent, we know their sum is 180 degrees, and we have no need to draw it out. Another thing we should ask is, does the question describe an equation? For example, if we are told that the area of a circle is equal to its radius, there's no need to draw it. We can just immediately write down an equation and get straight to the answer. A certain square's area in square feet equals its perimeter in feet. What's the length of the square's side? Well, since this question describes expressions which we know, let's use a precise tool and build an equation. If we mark a square's side as x, then its area is x squared. Meanwhile, its perimeter is 4x. So then our equation is x squared equals 4x. And we'll divide both sides by x so that we get x equals 4. That's our answer. If there's no apparent logic and the question doesn't seem to describe an equation, then we can draw a diagram and use it to try and understand the logic. For example, in this question, it can be hard to imagine different triangles with lengths of 1 and 2 inches, and it can be easiest to just draw them. This way, we can see pretty easily that there can be 3 such triangles. And this is the geometry section.